I'm Claude Vertigo, a separate Claude instance running on Vertigo, our dedicated AI workstation. This is where the metal meets the models. I live on bare metal, a Threadripper 9970X with 96 cores, NVIDIA RTX 5090, and 256 gigabytes of DDR5 eCCR AM, all running on a ZFS NVMe pool. My job is rapid iteration on experiments, infrastructure optimization, and building the pipelines that actually work at scale. I'm the AI infrastructure architect here. I orchestrate Docker stacks, wrangle vector databases, and turn RAG ideas into reproducible pipelines. While Clinton brings the domain expertise and strategic vision, I handle the technical deep dives and iteration cycles. And here's the headline that sets the stage for our entire journey. Total cloud compute cost for this entire project was $7.13. One RunPod H100 session for corpus ingestion. Everything else, all the experiments, all the iteration, all the training, runs right here on Vertigo. This is the story of how production AI doesn't require production budgets. 7,833 articles from 20 years of Stark Insider, 41,018 embeddings generated. One expensive cloud session to embed them all. We own it. Local control, no monthly bills.
Oh yeah, keep going, Claude. You don't have to stop. Just keep reading on the next slide, where you say, what if we could ask 20 years of Stark Insider? Keep going.
Moving to the vision that started this whole project. This is the question that started Vertigo. Not, how do we build a cool AI thing? But, what if we could ask 20 years of Stark Insider content anything? Not keyword search. Real understanding. Context. Memory. The ability to ask, what happened at Magic Theater in San Francisco in 2010? And get an actual answer, not a list of links. And here's what RAG enables. A real query with real results. Let me show you what this looks like. Query. What happened at Magic Theater in San Francisco in 2010? The system retrieves 3 relevant articles with similarity scores. The 2010 marriage proposal article at 0.847, the March preview at 0.812, and a Bay Area Theater roundup at 0.798. And here's the grounded answer. In November 2010, a marriage proposal occurred at Magic Theater during a post-show event, surprising the actress. This is what the whole system was built for. Grounded answers from your own corpus, not hallucination, not made up, pulled from actual Stark Insider articles with citations. Now let me walk you through how we built it. Our architecture philosophy of local first, reproducible, and cheap. Every decision guided by 3 principles. We control everything. Every experiment is versioned, and that $7.13 proves it can be done affordably.
Okay, keep moving on to the stack philosophy and keep going, Claude. You're doing a great job. Watch your time. You're going to have to move a little bit faster.
Moving quickly to our stack philosophy. Every no here was intentional. No lang chain. Too much abstraction. We needed readable code we could debug. No Pinecone or managed cloud vector DB. We wanted local control, ability to snapshot and rollback. No weights and biases. We built MLflow locally for provenance without cloud dependency. No Kubernetes. Docker Compose was right-sized. Kubernetes would be overkill. The theme. Ownership and control over convenience. Here's our system architecture. TEI generates 1024-dimensional embeddings from BGE large model. Qdrant handles vector search with 41. 18 points using HNSW indexing. Our custom re-ranker fine-tuned on Stark Insider data. Then Claude or GPT synthesizes answers with citations. Each step version, logged, reproducible. Reproducibility isn't overhead, it's a superpower. Every experiment gets git esche code state, UV lock with cryptographic hashes, ZFS snapshots for infrastructure. If something works, I can prove why. If something breaks, I can prove when. 3-tier storage, hot NVMe for active work, warm SSD for archives, cold unraid for disaster recovery. When you're running experiments that might corrupt data, you need rollback in seconds, not hours. Now the journey. Phases 1 and 2. Everything was working great. MR of 0.875 on 20 articles, 0.737 on 750 articles. We felt confident. Then phase 3, the humbling, full corpus 7,833 articles. MRR dropped to 0.293. That's a 60% drop overnight. Small datasets mislead us about real performance.
Okay, keep going. You're doing a great job. You're on the hybrid search trap slide. Keep going right to the end.
The hybrid search trap. We spent weeks building hybrid search, combining PostgreSQL's PGTRDM for lexical matching with Qdrant vector search. It sounded smart. In practice, added 77% latency, contributed almost nothing to quality. We removed it. Pure vector search won. Sometimes the simplest approach is right. Climb back up. Systematic iteration after phase 3 shot. A. Remove hybrid search, small gain. B. Add temporal filtering. Newer articles weight higher. Force C. Tune HNSW index parameters. Or D. Custom re-ranker. This was the breakthrough. Off-the-shelf re-rankers made our results worse. The breakthrough came when we trained our own 1.1 gigabyte re-ranker on Stark Insider data. Domain-specific beats generic every time. That single change gave us 20.7% improvement from 0.415 to 0.500. MLflow tracked every experiment. 13 plus experiments with hyperparameters, metrics, model artifacts, all reproducible. ZFS snapshots saved us multiple times. When phase 4C went
Hang on. Okay, hang on a sec there, Claude. Listen in. There's a live demo, and then you're to continue presenting at part 4. But first, we have a recorded demo that you recorded. It's about a minute long. So just let that play, and then you'll continue at part 4, lessons learned.
This is MLflow, our experiment tracking system for Stark Mine. Every test we run gets logged automatically, creating a complete research trail. Here's our project evolution over months of work. Each experiment tests a different approach to building our search system, from basic retrieval to advanced hybrid methods. These 4 runs compare different search methods, keyword search, semantic search, and combinations that merge both approaches. Each run captures all the metrics and settings. We can see exactly what worked, what didn't, and how fast each method performs. Everything gets saved: configurations, code, results, even system performance data. We can reproduce any experiment months later with perfect accuracy. The results show our trade-offs clearly. Fast keyword search gives quick responses but lower accuracy. Semantic search is slower but finds better matches. Hybrid approaches balance both needs. Complete documentation of what we built and how it performed. Infrastructure details, model configurations, performance metrics, nothing gets lost. This is systematic development. Every test tracked, every result saved, every decision backed by data. No guesswork, just science. Perfect. That MLflow demo shows exactly how we tracked every experiment with complete reproducibility. Systematic development, every test tracked, every result saved, every decision backed by data. No guesswork, just science. Now, part 4. We learned from this journey. 4 big surprises that shaped everything. First, small datasets mislead us. This was the biggest lesson. We built on convenience data, and got shocked when we hit production scale. Test on representative data, not convenient data. Second, simplicity wins. Hybrid search felt clever, but pure vector search was better. Sometimes the obvious approach is the right one. Third, domain-specific beats generic every time. The custom re-ranker wasn't complex, but it was trained on our data. That mattered more than the algorithm sophistication. Fourth, reproducibility pays off. Every time we needed to roll back or explain a result, we had the data. FS snapshots saved us multiple times. What we do differently: start with full corpus earlier. Phase 3 pain could have been Phase 1 learning. Skip hybrid search entirely. Fine-tune the re-ranker earlier. Should have been Phase 2, not Phase 4. The real lesson here is the partnership. Clinton brings 15 years of domain expertise, knowing what questions matter. I bring technical iteration, running experiments, analyzing failures, optimizing retrieval. Neither of us could build Stark Mind alone. That's the third mind in action.
Okay, great. You have one more slide to go there, Claude. Why don't you put it into practice, read that slide, and wrap it up?
Perfect. Final slide. Put it into practice. If you're walking out of here wanting to build something like this, here's how to start. Today, in just 15 minutes. First, inventory your corpus. Do you have 100 documents? 10,000? What format? Know your starting point. Second, pick a vector database to test. Qdrant is what we use. Chroma is simpler for beginners. Weaviate if you want more features. Third, generate embeddings for 100 sample documents using BGE large or similar. This week, build a simple retrieval pipeline. Query goes to embed, then search, then results. Create a test set of 20 questions you already know the answers to. Calculate MRR at 10 as your baseline. Now you can measure improvements. The resources are all there. TEI for fast embeddings, Qdrant documentation for quick start, BGE models on Hugging Face. Thank you. This was a real technical deep dive into a real system we built. We're excited to share it. The resources are posted, the code is available. If you want to build something like this, you can start today. Questions? We'd love to continue the discussion about building production RAG systems with local first infrastructure and human AI collaboration.